Alright, so moving on, we're going to look at something new here, and just to start off here, I'm going to give you 2 points on a Cartesian plane, and I want you to find the distance between them. So I'm giving you the points C, which is at 1, 3, and D, which is at 5, 8, and I want you to find the length of the line segment joining them. Okay, so again, if you just want to put this on a diagram here, you got your 2 points right here, and I want to find the length of this line segment right here. Okay, so think about how you might do that, and we're ready to go through it together. See if you can get an answer, and push play. We'll go through it. So your first thought might be, if you want to find this length here, and obviously you can't necessarily take out a ruler and measure it because we're dealing on a Cartesian plane, there's units here, is your first thought might be to create a right triangle here. So you might draw the horizontal distance here and the vertical distance here, and try and figure out, again, your distance from there. So again, if you're looking at your x values here, we're going from an x value of 1 to an x value of 5. This is a distance of 4. And along the y, along the vertical components here, you're going from 3 up to 8. So this is a distance of 5. So if you want to figure out this distance here, what you've actually created here is a right triangle. And you can say that, okay, this distance, so d squared is going to be equal to 4 squared plus 5 squared. Okay, so if we have 4 squared plus 5 squared, again, using Pythagorean theorem from middle school, grade 9, we can solve for this. So 4 squared is 16, 5 squared is 25, and that's all equal to d squared. So we're saying that d squared is equal to 41, and that d would be the square root of 41. So if we're trying to figure out the length here, we're saying that that distance is going to be square root of 41 units. Okay, so again, just using Pythagorean theorem there, we're actually able to figure out the distance between those two given points. Now, if you want to generalize this, you could actually create an equation to figure out the distance between any 2 points. I mean, let's say that instead of this being C and D and 2 known points, C was the point that we're going to call x1, y1, so 2 generic x values, x and y values that we don't know. And the other point here would be called x2, y2. Okay, we can still figure out that distance just by looking at, again, what's changing from your x values and what's changing from your y values. So just by creating a right triangle here, so I'm going here, just looking at the x's here, I'm going from x1 to x2. So this distance here would be x2 minus x1. Looking at my y values here, I'm going from y1 to y2, so my distance would be y2 minus y1. So I could create a general equation there using my x and y values for my 2 points. So I could say that d squared is equal to my change in x, so x2 minus x1 all squared, plus y2 minus y1 all squared. So no matter what the points are, I mean, again, I gave you C and D up here, so you knew what x and y were for each point. But no matter what the points are, as long as I know their x and y values, I can in theory solve for their distance. Because once I have this, my distance would be equal to the square root of both sides of the equation. So I have the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And what this is right here is a formula to find the distance between any 2 points. So it's just formally called the distance formula. Okay. So once we have that, again, any 2 points I give you, I want to find the length of the line segment connecting those 2 points. I can calculate using this formula right here. Okay, so let's put that to work. So there's my formula right there. So here's a situation. I'm giving you 2 points. So E and F are the endpoints of the diameter of the circle. Number 1, I want you to find the coordinates of its center. Okay, so again, get an idea of what's going on here. I have a circle. Remember, it's endpoints of the diameter I'm giving you. So diameter is a line that goes all the way across a circle, passes through the center. So I'm given here, this is the point, let's say this is F at 6, 5. And this is E at 1, negative 11. And I want to find the coordinates of the center. So your first thought might be, well, I'm not looking for a distance here, I just want to find the coordinates of the center. And hopefully you recognize here that this center is going to be halfway. It's going to be the midpoint between my two endpoints right here. So I don't need to use distance formula just yet. I can use what I did last lesson. So my center is going to be equal to the average of my x values. So I'm going to have 6 plus 1 over 2. And the average of my y values, which is 5 plus negative 11 all over 2, which simplifies into 7 over 2, and 5 minus 11 is negative 6, so negative 3. So the center of the circle will be there at 7 over 2, negative 3. Okay, so now that I know this point right here, part B asks me to find the radius of the circle, and it says round to 1 decimal place. So there's two ways I can go about doing this. If I want to find the radius would be either the distance from the center to either of the two endpoints, either from C to F or from C to E, or I could find the diameter, the length between E and F, and divide it by 2. Either one works. I'm actually going to, because I don't want to worry about having divided by 2 afterwards, I'm going to go straight to finding the radius. So I'm going to find the distance between C and F. And I'm going to choose to do F because there's no negatives inside those points, so a little bit easier to work with. So I'm trying to find the distance between C and F. So I'm just going to list my points here just so I have them handy. So C is at 7 over 2, negative 3, and F is at 6, 5. So again, if I let C be x1, y1, and F be x2, y2, I should in theory be able to solve for the distance. So I'm going to write out my distance formula here. Okay, and I'll put everything I have from my 2 points. So looking at my x values here, I'm going to have 6 minus 7 over 2, all squared, and then 5 minus negative 3. Squared. And again, the order in which I subtract them doesn't actually matter because the distance is going to be squared afterwards anyways, but you should try to be consistent here. So if I'm choosing F to be my second point, x2 and y2, just make sure C is x1, y1. Okay, and then from here, it really just is a matter of simplifying as best you can and going through the steps. So work along with me here and try to make sure you get the same thing. So 6 minus 7 over 2 is 5 over 2. 5 minus negative 3 is 8. Okay, so 5 over 2 squared is 25 over 4. And 8 squared is 64. And again, just simplifying from here on in. So 64 plus 25 over 4 is 70.25, or 281 over 4. I'll use decimals here. So my distance is going to be the square root of 72.25 units. Now, if I ask you to leave the answer exact, you could leave it like this, because again, there's no rounding here. It's all under the square root. I haven't done anything that would cause me to round to a couple decimal places. However, this particular one I said round to 1 decimal place, so you can take the square root. So that gives me approximately, for the distance, 8.4 units. So the radius of this circle is about 8.4 units. Okay, so hopefully this makes sense so far. And again, once you know what you're doing here, it just takes some getting used to using the equation. It's a little bit easy to make a mistake with all the negatives and the squares going around. So you just gotta make sure you don't make a mistake there. Take your time, and you'll eventually get to work out. So let's take it a step further here, and now we're going to look at a triangle with vertices at 3, 3, 4, 0, and 1, negative 1. And I'm going to ask you if the triangle is scalene, isosceles, or equilateral. So let's just go over those definitions first. So if a triangle is equilateral, that means that all sides are the same length. So all sides and angles actually are the same. Okay, isosceles means you have two identical sides. And of course, that would mean that scalene would mean three different sides. Okay, so I have to keep that in mind. So if I'm trying to classify what kind of triangle it is, what I need to figure out is the side lengths for all three sides. So once I have my triangle drawn in here, so I have that A is at 3, 3. I have B down here at 4, 0. And C is down here at 1, negative 1. Okay, so I have this triangle right here, and what I'm trying to figure out is if it's scalene, isosceles, or equilateral. So what I'm going to need to do is find the length or distance between every pair of vertices, so every side length needs to be found. So I'm going to let you try that on your own. You're going to need to find three things here. The distance from A to B, again using the distance formula. The distance from B to C. And finally, the distance from A to C. You're going to find all those and compare them to each other, and push play and ready to see the answers together. Okay, so take a second here and check your answers. So I showed the calculation for the distance from A to B right here. So I take my x values, I go 4 minus 3 all squared, and then I do 0 minus 3 all squared, add those together. So I wind up with the square root of 10 for my distance, for my length there. So I repeat the exact same process. I didn't show the calculations here, but you should get root 10 for the length of BC and root 20 for the length of AC. If you're having trouble getting those answers, do let me know. We can run through the algebra together. It's likely just a little sign error somewhere. So once we get these three answers, we can take a look and say that, okay, two of my lengths are the same. Both AB and BC have a length of root 10. The third side's a different side, so I can say that triangle ABC is going to be isosceles based on the fact that two of the sides are the same. Okay, so again, if I'm asking you to qualify or classify a specific triangle, one thing you'd have to do is to check what type of triangle it is based on the side lengths. So part B asks you to take it a step further and say, okay, is the triangle a right triangle? So what we're going to look for is if there's going to be a right angle in here. So think for a sec how you might be able to tell if there's a right angle in there. There's two ways you can go about this. So one way is if it's a right triangle, there's a 90-degree angle. And if there's a 90-degree angle in the triangle, that means the slopes will be negative reciprocals of each other. That's one of the things you saw back in grade 9, right? If two slopes are negative reciprocals of each other, it means they are perpendicular. So what we can actually do is find the slopes of all three sides and see if any are negative reciprocals of each other. Okay, so let's try that. I'm going to find the slope of AB, the slope of BC, and the slope of AC. Okay, I'll do the first one together with you. So the slope of AB is going to be rise over run, so I'm going to have y2 minus y1 is 3 minus 0 over x2 minus x1, which is 3 minus 4. So that's going to give me 3 minus 0 is 3, 3 minus 4 is negative 1, so I get a slope of negative 3. Okay, I'd like you to take a second, repeat this process, find the other two slopes, and then compare them to each other. Okay, so I calculated my remaining slopes there. The slope of BC was 1 over 3. The slope of AC was 2. So what I'm noticing here is if I look at the slopes for AB and BC, AB is a slope of negative 3, BC is positive 1 over 3. These are negative reciprocals of each other. So what that's telling you is that the side AB is perpendicular to the side BC. So the conclusion is telling you that triangle ABC is a right triangle. Okay, so now it might be one of those things where if you looked at the picture that you drew, you might be able to sort of visualize, it looks like there might be a right angle there, but that's not a proof. The way you can actually prove it is again by looking at the slopes. So there actually is another way you can show this is a right triangle. We'll look at that in part 2 and then go through the final example together there as well. So we'll see you over there.